Okay, so we started off with what is mole, since the mole is the center screen now. So you can see that we are actually taking or converting different substances, quantities into mole. So if we start from the extreme left-hand side, the solids, when they are taken in mass, grams, kilograms, pounds, maybe, they can be converted into mole. This is the formula that we are already done with. Now, the quantity, whenever just counted simply, for example, if you go to market, you purchase eggs or bananas in the form of dozens, you can simply count them. So we can convert counting into moles. As far as volume of liquids and gases is concerned, which we usually take in our daily life, we go with decimeter cubes or liters or centimeter cube or maybe milliliters. So the common fizzy drinks, Coke, Sprite, Fanta, you name it, they're all available in the form of 250 cubic centimeter or half a liter, 1 liter, 2 liter, maybe even bigger packings. So we take them in the form of volume. Volume can also be converted into moles. And lastly, there are solutions for which the concentration is given usually in mole per decimeter cube. So our juices, our medicine, syrup, stuff like that is purchased usually in daily life uh, based on those units. Now we can also convert that into moles. There are four state symbols that we use in equations. S stands for solid, L stands for liquid, G stands for gas, and AQ stands for aqueous solution or solutions made in water. We are supposed to deal with as a chemist or being a chemistry person through the help of balanced chemical equations. So we need to be familiar with mole. So mole actually works like a chemist's secret unit. He can convert any quantity that he's going out to the market and purchase it in, and he can convert it into moles, and then he can keep on doing the calculation no matter he was previously dealing with masses or volumes or concentrations or simply counting. So mole is actually like a secret unit convertible from any one form to another form, and this actually gives chemists the edge. Moving on, we started off with a simple formula, mass mole conversion. The number of moles can be found out if we have mass in grams. If we don't have mass in grams, we can always convert them. Here's the key on the top right portion. 1 kilogram is equal to 1,000 grams. 1 metric ton or 1 ton is equal to 1,000 kilograms, maybe 1 million grams, or 1 gram is equal to 1,000 milligrams or 10 raised to power 6 micrograms. So that's the key for conversion. If you have the mass in grams, you divide it by molar mass. Molar mass is something that we always take from periodic table, usually represented as MR, as a combination of different elements as given in the formula, and the value is always taken in gram per mole. Both the grams cancel out. We have the value, the units, mole. Mole is written as MOLE. The units, however, are written as MOL only. We don't write the E with it. So our first question was to convert mass to moles. So I gave you different questions. You solved them. You got the answers right. Moving on. The second was to convert moles to mass. In this kind of questions, I gave you the moles, and you were supposed to go with a little bit of a rearrangement with the formula that you can see at the bottom right corner of your screen. So mass is equal to moles into mR. We rearrange the formula given on top, and that's how we are able to get the values of mass. If we need any conversions, for example, in step two, question two, part two, the examiner is asking for the mass, not in grams, but in kilograms. So first we need to calculate it in grams, and then we need to convert it into simply kilograms. So I hope this is as far as we've come on this chapter. Let's start with a new formula today. So let me share my screen with you. Okay, that's not the right screen, definitely. Okay, so just a minute. Yeah, there we go. So today we are going to talk about number of moles when they are converted from the quantity simply means in counting. So the number of moles is equal to number of particles, any number of particles, and it's literally the counting for number of particles. Just a minute, you'll have to bear with me. So that's number of particles. And we also divide it with a constant. This time I'm going to introduce you to a new constant. We call that Avogadro's number. Avogadro is the name of the scientist, and he actually proposed a specific number, and he told us that this number is the number of particles present in 1 mole of any substance on the planet. It does not matter whether it's a solid, it's a liquid, it's a gas, it really does not matter. What matters is that if the substance is 1 mole, that would be the number of particles. And I'm also going to write the denotation. Denotation is capital N and capital A, and stands for number. A stands for Avogadro's. I think that's pretty obvious. So let me write the number over here, and it's a really big number. It's 6.02 into 10 raised to the power 23. Now that's really a big number. If I actually don't write it in scientific notation, and I write it in symbol numbers, so it would be something like 602, and then will have to write like 20 zeros after it, maybe 21 zeros after it. So that would be a huge number if I write it this way. So what do? We write it in scientific notation, and this number is the number of particles in 1 mole of the substance. So you can actually define Avogadro's number separately. Number of particles in 1 mole of any substance. Sometimes this definition is extended about temperature and pressure, maybe room temperature and room pressure are mentioned. Sometimes this definition is extended and the word particles is described, since particle is actually a broader category word. When I use the word particles, I might mean atoms, I might mean molecules. This is pretty easy. I might mean ions, or maybe formula units. Okay. Now, let me clarify myself by saying atoms, we know they actually belong to elements. When I use the term molecules, I mean covalent compounds. Ions are actually represent ions, so they are not representing anything in specific separately from the word itself. And when I say the word formula units, I mean ionic compounds. So when I say the word particles, actually particles represent all of these. So particles is a bigger category word which we can write if we don't exactly know what that is. That actually comes as a trick. Okay, so whenever you want to keep yourself safe, don't want to make a mistake, you don't exactly know what kind of particles those were. If you know, and if the examiner wants you to be specific, go ahead, be specific. If you're talking about simply iron, you know iron is an element, you can go ahead and write atoms. If we're talking about after a specific change like loss or gain of electrons, you know it won't be atoms anymore, they will be converted into ions. So you may go ahead and mention them as positive ions, maybe negative ions, whatever the case may be, whatever the question requires you to write. So, but if we are talking about a covalent compound, go ahead and use the term molecules. If you're talking about ionic compounds, please use the term formula units. We only use the word ions with ionic compounds if the ions have gotten separated, which it does, and we either melt an ionic compound or put it into water to form a solution. If it's soluble in water, it could be converted into ions separately. So that we already know from the bonding chapter, chapter number 3, coming back to chapter number 6, the part where we are at. This means that when I write this whole formula, it's actually easier than the previous formula. Okay. So if it's easier than the previous formula, this should then be better. Oh, too bad. Okay. All right. Why am I calling it better? Let me tell you, in the previous formula, the denominator was to be calculated from the periodic table, which actually requires for an extra step from you. This time, the denominator is going to be fixed. Pretty easy. 6.02 into 10 raised to power 23. Memorize it once, the formula is going to come easy to you. Now, when I talk it about this way, let me tell you that this formula is one of the least used formulas of this chapter in past papers. So we're just going to practice it a little bit. Let me come up with both kind of questions. Number one, convert number of particles to number of moles. And this is the question where you're going to use the same formula in the same form. You are not supposed to change it or rearrange it. Question number two, however, would be a little bit different. So we are going to convert number of moles into number of particles. So number one, one 1.024 Let's just keep it to 2 questions per part. Remember, you might need a calculator, a copy of periodic table, and something to write with along with a rough piece of paper. So go ahead and grab it and we'll start working. You can actually start working with question number one, part one, if you already understand how to proceed with it. And during that time, I am going to write 2 more parts to question number two.
Sir,
जी बेटा
नंबर ऑफ पार्टिकल्स की जगह हमने वाटर का mr लिखना है या फिर the one you
number
have
of
given?
molecules. Number of
Okay.
molecules. That's why I've given these words as a key over here. So these words will give you the idea that this is number of particles, because he's not going to use the bigger, broader term every time. He might be very specific. So if you know atoms, molecules, ions, and formula units are actually representing particles, it should be easier for you to guess what that was. In this case, you do not need the periodic table for this specific question, since it's the easier form. But I wanted you to keep the periodic table because I am going to go with somewhat difficult form right after this one. Let's first go with these 4 parts, 2 parts to question number one, 2 parts to question number two. During these, you're not going to require the periodic table at all, because you'll be simply either dividing or multiplying numbers that are already written on your screen, right?
Yes, sir.
Wes, I hope you are also getting a hang of it.
Yes, sir, to some extent, but Yes, sir. I'm trying to understand.
It's okay. For the first question, I'll just solve it for you. It would be easier for you to solve the second part of it. And I'm going to do the same with first part of question number 2. It would be then from there on onwards easier for you to what to do in these kind of questions. Solving a few questions will give you a really good idea how to do that.
Yes, sir.
Sir, I got the answer for this part.
Question number 1, part 1.
Yes.
Just a minute. Okay, and what's the answer?
170.09.
170.09 mole.
Yes.
170.09 mole. Okay, and I hope what you did in this question was pretty simple. 1.024 into 10 raised to power 26 was divided by, as the simple formula says, 6.02 into 10 raised to power 23.
Yes, sir.
Good.
And for the other part, I also did that part.
Okay. Before we start with part 2, do you have the same answer for division, Awais, for question 1, part 1? Awais, you there? Okay, I think he might be away to grab a calculator. Let's continue with you, Reba. Question number 1, part two's answer.
Sir, I got 1.661 multiplied by 10 raised to power minus 14.
Okay, good. But that's just a number. Remember always to say the units along with the number. That's how your answer becomes complete. In second question, remember the denominator and number of moles are multiplied by one another to get the number of particles. So it's pretty simple. Whatever value I've written in the question, multiply it with 6.02 into 10 raised to the power 23. So it's going to be really easy for you.
Sir, I got the answer for the first part of question 2.
Go ahead.
It's 6.02 multiplied by 10 raised to power 20 multiplied by 10 raised to power 19.
19, right.
Yes.
6.202 into 10 raised to the power 19 and formula units. If you're sure that these are formula units, since you know from this formula NaCl compound, we can write this. If you're not sure, it's pretty easy. Simply write particles, 6.02 into 10 raised to the power 19 particles. I hope that makes sense. Does it?
Yes, sir.
Good. Go ahead with the last part. I am aiming to complete 2 formulas today and not just 1.
Sir, I got the answer for the second part. It's
Hmm,
6.16 multiplied by 10
6.1.
raised to power 6.16
Okay,
multiplied by 10 raised to power 25.
25, and these are atoms because it's a single element. Well, if you don't know these are atoms, simply write particles.
Okay, sir.
Are we good?
Yes, sir.
Okay, Wes, to get the point. Wes, can you hear me? Okay, I hope he understands it. Okay, since he's not responding, so let's move on. So we are going to resume with the third formula. And that is for number of moles, the unit of which is going to be mole itself, volume, which is always taken in decimeter cube. Remember, just like mass, the standard unit was grams, and whichever unit the question was posed in, we were pretty much used to convert that into grams before we put it into the formula. So we are going to do the same with volume, all right?
Yes, sir.
Now, I am going to mention a couple of things over here. And also, this formula is number of moles, the unit for which is moles, volume in decimeter cube divided by molar volume, the value of which is very specific, 24 decimeter cube per mole. Now let's define molar volume first. Okay, so any gas, it can be oxygen, hydrogen, carbon dioxide, nitrogen, name a gas, it does not matter which gas that is, any gas at RTP, and actually RTP stands for room temperature, which in our case is 25 degrees centigrade, and room pressure. RTP stands for room temperature and pressure. The room temperature in our case is actually 25 degrees centigrade, and room pressure in our case is usually 1 atm or 1.01 into 10 raised to 5 pascals. Carries of volume equal to 24 decimeter cube divided amount of gas equals 1 mole. Okay, this might seem a very big statement, but the statement is very easy. 1 mole of any gas at room temperature and pressure has a volume of 24 decimeter cube. That's how simple it is. Room temperature is usually 25 degrees centigrade. Room pressure is 1 atm, or atm stands for atmospheric, a unit we usually do not discuss as much in chemistry as much as we do in physics. So you're going to learn the same unit in physics. If not, for the unit of pressure, Pascal or kilopascals are the common units we discussed about even in physics. So it's really easy. Again, once again, we are not going to talk about the periodic table since the denominator is always going to be 24 and you can easily memorize that. So it's just the volume and the number of moles for which we need the interconvertible questions. So let's go on with the questions. And ready, since my questions are always bifurcated into two types for these starter formulas. So question number one, convert.
Sir,
Yes.
what is it written? Which value is it written before 10 raised to power 5 pascals?
1.01 multiplied by, it's 1.01. This is one.
Okay, sir. Thank you, sir.
Okay. So convert volume to moles is our first question. Again, the second one is going to be opposite. Convert moles to volume. This is going to be our second question. Let's start with first one. I have no idea why it wasn't such a big problem today. Thank God. I was expecting I might lose more stuff. Okay, so part one. And by the way, this reminds me that I still need to give you the key. So let's talk about the key. So 1 meter cube is equal to 1,000 decimeter cube. 1 decimeter cube is equal to 1,000 centimeter cube, while 1 liter is equal to 1 decimeter cube. 1 milliliter is equal to 1 centimeter cube, and actually 1 liter, and this must make complete sense, is equal to 1,000 milliliters. So if I say 1 meter cube, you already know how to convert it into decimeter cube before you put the value in the formula. I hope you get the point since we have practice questions like these before. Okay. I'm gonna give you a little bit of a tricky. Let's not give you tricky question in this part. I'll give you some tricky questions in the next part. In question number 2, let's stick with easier questions in question number 1, so that you get used to this formula before you go on with the difficult question.
Sir,
Yes, beta.
is the answer for the first one 41.6 mole?
Perfect. 41.6 mole. So you already have the answer to the first one. Okay.
Sir, for the second part, is it 0.0825 mole?
0.0825. I guess you're right. I haven't done this exactly myself, but I guess you're right. If you have divided 19.8 by 24, actually 19.8 by 1000, and then that by 24, you're right.
No, sir, I did 19.8 divided by 10, and then I did it, then I got 1.98, and then I divided that by 24.
Then that's not correct. There are 1000 cubic centimeter and 1 decimeter cube. So you need to divide it by 1000, not by 10.
Yes, sorry, I made the mistake. Yes, I get it.
Correct your answer and then let me know what the correct answer is. And I'm gonna erase this one since this one's not correct. Well, it would, I guess, be 8.25 multiplied by 10 raised to the power minus 4. Maybe. I'm not sure. Just doing it in my mind.
Sir, the answer is 8.25 multiplied by 10 raised to power negative 4.
Yeah, I was saying the same. 8.25 multiplied by 10 raised to power minus 4. Okay, good. Let's move on to part 3 then.
Sir, for the third part, I'm getting 0.0975 moles.
0.0?
0.0975 moles.
Yeah, seems right. So you first converted the centimeter cube into decimeter cube. The answer came up to be 23.4. Isn't it supposed to be 0.975 instead of 0.0975?
Sir, I'm getting 0.0975.
So yeah, you're right. 0.09. That is correct. Okay, moving on.
Sir, I don't get question two. How are we going to convert mole into decimeter cube?
You simply take the denominator on the other side. So whatever number I've given you, you multiply it by 24, your answer comes out in decimeter cube. That's how easy it is. Question number
Oh,
two has always been a multiplication question in which we take the denominator and multiply it with the number that I've given you. So the denominator is 24 and it does not change in this question.
so is the answer 24 for the first part?
Yes, it's 24 decimeter cube for the first part. But in the second part, I've specifically asked for centimeter cube units. So you might need to do a conversion after applying the formula.
Sir, is the answer 47.52 decimeter cube?
47.52. Decimeter cube, your answer was supposed to come in centimeter cube. I specifically
Oh,
asked the answer in centimeter cube, not in decimeter cube. So once you have taken out the answer automatically comes out in centimeter cube, decimeter cube, sorry. Then you need to multiply it to convert it into centimeter
oh
cube.
yes, sorry, sir. I multiplied the answer and it's 47.52. But I wrote decimeter cube. I made a mistake in units.
Yeah, that is correct. 47.52 centimeter cube. Okay, the third one is really different. You're not going to really convert moles into volume at first because you're first going to convert mass into moles and then moles into volume. So you really need to apply the first formula for moles that we started off with and then this one. So using the very first formula, moles is equal to mass over molar mass, convert this mass in grams into moles. And then you can use this formula to convert it into volume. Go ahead.
Sir, is the answer 4.992?
How come? How come is the answer 4.992? Are you doing it correctly? Okay, let me tell you there are two steps to this one. First is mass over mass which is taken in grams, which is given in the question, MR, and MR should be of methane, CH4. Then once we have the number of moles, we'll get the quantity over here. We use these moles, multiplied it by 24, and then we get our answer. I hope you're
Yes,
doing
sir.
it right.
I
So
did the
what's your
same.
MR?
It's 48.
That is incorrect. How come it's 48? It's CH4. There are 4 hydrogen atoms. There is 1 carbon atom. How come it's so big? 1 carbon atom means 12. You're not going to multiply it with anything. And since hydrogen only weighs 1, 1 into 4 is equal to 4. So 12 plus 4 is equal to 16. How come the answer is 48 for
Oh,
methane?
sorry, I multiplied 12 with 4.
Oh, actually 12 would be multiplied by 1 and 1 would be multiplied by 4 and they both are added. So the answer comes out to be 16.
Yes.
Okay, let's do it with 16 and then tell me what your answer is.
It's 15.
It's
15
15.
decimeter.
15 decimeter cube. Perfect. So if you go with these two formulas one after another, your answer comes out to be 15 decimeter cube. Okay, these two formulas are both for moles. So either you can use step by step or you can use them in conjunction. If you're supposed to use a formula in conjunction, that's how it works. Since both of the formulas are equal to moles, on this side we are taking volume in decimeter cube and over molar volume, which is basically just 24, right? And on this side, we had mass, which was in grams, divided by MR. So since they're both equal to moles, actually what we can do is that we can simply erase this part out and we can get them out equal to one another. And since I want this specific values, what's going to happen is that molar volume is going to go over there in multiplication. So let me rearrange the whole thing. So what I should do is that multiply this by molar volume, the value for which is 24, and that is equal to volume, and I can easily erase molar volume from here. There you go. So I can use two formulas to create one. So put your value of mass, that is 10, divided by 16, multiplied by 24, you get your answer. And the answer would come out to be 15. So if you remember conjunction formulas, when two formulas are combined into one, you can use them directly or you can use them step by step. I've found that most of my students are easier with step-by-step answers. So if you find this one easy, go ahead with whichever method you find easier. And I usually ask my students, don't try to become heroes. Don't think about that. If I use formulas in conjunction, I might be a hero in the eyes of the whole class. The purpose is not to become a hero. The purpose is to do it correctly and get a good grade. So it really depends upon whichever idea or whichever strategy you like more, you find it easy so that you can get the marks you want to. All right,
Yes, sir.
good. Any questions?
No, sir, it's clear.